Hello everyone, I'm Tanushri. In this video, we are going to learn about selection sort. Let's see the agenda for today's video. The first topic is introduction, and the second topic is algorithms, and third topic is implementation, and fourth is conclusion. Let's get into the video. Let's see the introduction part. So, what is selection sort? Selection sort algorithm is an in-place comparison-based algorithm in which the list is divided into two parts: the sorted part at the left end and the unsorted part at the right hand. The smallest element is selected from the unsorted array and swapped with the leftmost element, and that element becomes the part of the sorted array. Let's move on to the conceptual diagram of selection sort. Here I'm taking 15, 12, 17, 13 as an example for selection sort. This example I'm going to divide into two parts. The first part is a sorted array and second part is an unsorted array. The first element is taken as a minimum index. First step in the swapping is to find the smallest element. In this example, we have to find the smallest element. So we have to compare 15 with other elements. Let's compare with 28. 15, if we compare 15 with 28, 28 is greater, and again we have to compare with 17. 17 is also greater, and we have to compare with 12. So 12 is smaller than 15, so we have to swap. After swapping, we have to place 12 here and 15 in the place of 12. And next step is again we have to divide the array into two parts: sorted array and unsorted array. Next we have to start swapping with 28, not with 12. So we have to compare 28 with 17. 17 is smaller, but it is not a minimum element. So again we have to compare with 15. It is also smaller element, but is not a minimum element in the given array. So finally we have to compare with 13. So this is the minimum element. So we have to swap. In this step we have to place 13 here and 28 here. Okay, the next step is 12, 13, 17, 15, 28. Here we have to divide. Again we have to divide into two parts: sorted array and unsorted array. Okay, again we have to start comparing with the element 17, not with a 13. So we have to compare 17 with 15. So 17 is what greater than 15. So 17 is greater than, so sorry, uh, 17 is greater than 15. Okay, so here we have to swap. The sorted array is 12, 13, 15 and 17 and 28. This is the sorted array. For swapping, the condition is the first element is greater than the another element. The given element is greater than the another element. So this is the conceptual diagram of a selection sort. Let's see the algorithm for selection sort. What is algorithm? Algorithm is a blueprint of the program. Sort a given array by selection sort. For solving the selection sort, we have to give the input an array of 0 to n minus 1 of orderable elements. If we give that input, the output will be array a of 0 to n minus 1 sorted in non-descending order, that is ascending order. For I equals to 0 to n minus 1, do a minimum of 1 for j equals to 1 plus I plus 1 to n minus 1, do if a of j greater than a of minimum min of j. Swap uh, A of j and A of minimum. In previous, in the conceptual diagram, I'm taken the example of 15, 28, 17, 12, and 13, right? So for let's check this condition. If A of j means this one 15, 15 is the A of j, and A of minimum is in this array, the A of minimum is 12. Okay, if A of j is greater than A of minimum, we have to swap. So the next is 12, 28, 17, 15, 13. Like this we have to swap all the elements in the given array. Let's see the implementation of selection sort. This ash includes stdio.h is, we all know this is a library element. For traversing all the elements in the array, we are using for statement, that is for I of 0 is I equals to 0, I less than n minus 1, I plus plus. Uh, and finding the minimum element in the unsorted part of the array, we are using minterm equals to I, and again we are using for j is equals to I plus 1, j less than n, j plus plus. If array of j less than array of minimum or index, minimum term equals to j. For finding the minimum element in the unsorted part, we are using this conditions. Let's see, for swapping the minimum element with the left first element, we are using int temp equals to array of I. Array of I is equals to array min index. Array of min index equals to temp. Int main. Int my array is equals to, I am giving my array is equals to 64, 25, 12, 22, 11. Int n is equals to size of my array divided by size of my array of 0 in. This is the index, that is 50, 64. To perform selection sort, we are using the conditional selection sort of my array comma n. To print this sorted array, we are using printf statement. Again we are using for state condition, like for of int I equals to 0, I less than n, I plus plus. Again we are using printf statement to print the resultant string. If we implement this program in C compiler, the output will be 11, 12, 22, 25, and 64. This is the desired output. Let's see the applications. The first application is embedded systems, and the second application is pre-sorting for simplification, and the last application is teaching tool. Let's see the conclusion. Selection sort is not ideal for large data sets due to its inefficiency, but it has its uses. It's great for teaching sorting concept, handling small data sets, and working in environments with limited memory like embedded system. Its predictable performance can also be useful in specific real-time application, while more advanced algorithms are usually better. So thank you for watching my video.